All right. Well, thanks everybody for tuning in to the webinar. We're going to go ahead and get started. We've got a lot of great content to discuss, really specific to the physical operation and the usability of additive technology. So just a couple quick housekeeping items before we do get started. This webinar is going to be recorded. So for those that are in attendance today, you'll actually get an email shortly after with a link to the recording, so you can reference that and then share that with other members of your team. So no need to record your own computer screen or anything like that. You'll actually get the physical recording. And then it looks like we have a good volume of people on, so feel free to, I would say, present some questions throughout the call if it relates to the topics that we're covering. And then we'll do our best to actually answer those in the chat section throughout the course of the webinar. And we'll also do it probably at the end during a normal Q&A, so everybody can benefit from that. And if some reason we go really long here and GoToMeeting kicks us out, we'll be sure to follow up with you afterwards and definitely provide some clarity on those topics of interest. Okay. So for those of you that I haven't had the pleasure of meeting, my name is Charles Murphy. I'll be one of your hosts for today's webinar. I'm probably one of our more senior 3D printing specialists with Design Point. I'm in year 4 when it comes to kind of our additive agreements, and I basically focus a lot of my time on the Mid-Atlantic territory, which is really from New York to Virginia and everywhere in between. And then we also have specialists that are not necessarily on this webinar today, but they'll focus on our Northeast territory, which is from Connecticut all the way up to Maine. So really specific to our partnerships in additive, I've had the pleasure of fostering a lot of consultative relationships with about 300 plus companies over the past couple of years to really aid in helping them establish very sound additive strategies to help those companies really compete in this new era, this new global market. So the last webinar that we carried out, which was titled "Why Now and Why Additive," I enjoyed sharing a lot of my more recent findings specific to how our partners in additive are profiting from these economic times. Whereas today it's going to be a little bit different. I'm excited to show just actually how easy it is to operate this technology. I am not an application engineer. I'm a kind of a technical sales guy. So for anybody that is maybe in an engineering role, an administrative role, a CEO, president, high-level executive, hopefully this makes you feel a lot better. Knowing that I don't have a lot of experience in necessarily the engineering world, and I have one of these in my house, which I'll show you guys later, which is kind of the reason why we're here today, is to live look at both the composite technology that Markforged offers, as well as our metal system. Okay, so I'm also joined by my co-host, Andrew Garchik. He's a very talented application engineer here at Design Point. He directly manages our fleet of printers across all of our offices. Also a pretty good LinkedIn influencer, if anybody's seen any of his blogs. Big additive nerd as well, like many of us. And he'll also be manning the chat window while I'm speaking. So Andrew, I'll let you talk a little bit more to your roles with Design Point.
Yeah, thanks everyone for joining. Thanks, Charles. Really, you said a lot of it. I manage our metal and composite 3D printing facility in Clifton, New Jersey. That's where I'm at right now, speaking to you from. I no longer have that awesome beard anymore, though. Look at that picture. I got to get you an updated picture. I'm just going to swing around real quick. I'll just show you the facility. This is the Metal X right here that we'll be talking about. And then we have our composite machines over here. A bunch of different applications set up to show folks exactly what this technology is capable of. And on this side, we've got our Sinter furnace and our wash station that we will cover later as well. Aside from working out of this facility, I also am involved in the evaluation process. So when folks are looking at investing in this technology, I help out by looking at applications and finding applications and iterating parts and getting them in the best way for this technology. Also, I'm involved with training and installation. So kind of pre-investment, I'm involved at the time of investment, and then post-investment, I'm a member of the support team that supports our Metal X customers, our Markforged customers, just in general. That's about it.
Great.
Thanks.
Sounds good, Andrew. Thanks for sharing. And then lastly, I wasn't able to pull a picture in time, but we have another Design Point employee on the call. His name is Nick Finicaro. He won't be speaking a lot today, but he'll actually be manning the chat window. We saw a lot of questions in our last webinar. And Nick might also be reconnecting with you if you have any questions thereafter, or maybe you'd like to, follow up with more of an assessment, whether that's on-site or virtual. If there's more interest, in the platforms as we move forward. Okay. Great. So let's talk a little bit about what we can expect today. Right. So, first we're going to briefly talk to the company that, we all work for here at Design Point, and why businesses, seek us out over others when they need solutions to problems that they've really never experienced before. And then next, I want to briefly recap our conversation during the last webinar when we highlighted our strategic partner, Markforged, right? Design Point. We chose these guys about 4 years ago to represent, and why we feel so strongly about them, right? What are their major differentiators in the marketplace today? And then we're going to get into the meat of the conversation, which is all geared around an actual live look, a demonstration into both our industry-leading composite platform. I have an X7 currently in my household, so I'm going to be demoing that particular platform. And then we'll also speak to our best-in-class, our first-to-market FFF metal 3D printing platform, which is called Atom. And Andrew will go into a little bit more about those details because he's sitting out of our New Jersey lab, and Design Point wouldn't pay to have a metal system in my house. So unfortunately, I don't have that here to do a double look. And at the end, of course, we're going to take some time to answer some questions that are presented throughout the course of the webinar. And then we'll follow up there afterwards and make sure everybody's set. Sound good? Okay, great. So, well, if you're not already familiar with Design Point and what we do, it's probably not all that uncommon to think that Design Point is kind of like an OEM, like a Markforged or a SolidWorks, which is another side of our business, actually. We have so many conversations day in and day out about these brands that we represent, and we're definitely subject matter experts in everything we provide. That sometimes it just becomes an assumption, but in actuality, we are a a local growth advisory firm for design and manufacturing companies, and we've taken probably the last 20 years of engineering experience servicing a variety of different industries, and have helped establish really competitive advantages for companies in those areas of their business. And since we love everything 3D, our experience in that industry combined with our passion for really helping people allows us to propel companies forward so that they too can experience new lines of profitability or growth, even in the hardest of economic times, which I know many companies are seeing right now. And if you didn't already know, yes, we actually sell 3D software, we sell 3D services, and even training outside of the 3D printing technology that we represent, that we're going to be talking a lot about today. So, obviously we have a lot of good insight into, some of the right strategic initiatives that many companies should and definitely are focusing on today. Now, outside of having really fantastic offerings like a Markforged, we understand that you make decisions about who you do business with based on other things, right? So our key differentiators in the marketplace, or our three uniques, are one, active engagement. Right, so meaning we are continuously communicating prior to and surely after your investment. Our analytics-based support, right? So we're measuring our success by how well we support you, and we have a lot of metrics in place to ensure your utmost satisfaction. And the fact that we think like an owner of your company, right? That really goes back to being a trusted partner, a trusted advisor, and the company really understanding that we're here to focus on a lot of your business goals, the same ones that obviously you're focusing on day in and day out. Now, we also have a proven process, right? We're very calculated and strategic in how we engage with our customers. So we have a very formal documentation that we're happy to share with you, but it's just really about seeking to understand, who you are, what you do, setting the proper expectations, and sometimes even saying no, right? If we don't see the confidence or the ability to put a machine or software or services as a right fit in your business. And we're all about making it happen as well, right? We want you guys to unleash your greatest potential because we're very adamant about the fact that more is possible. And the more you interact with our company, the more and more that you're going to hear that motto from us. So why are you guys here today? Well, I would suspect that based upon the agenda for today, that most in attendance have little or no access to additive technology or 3D printing, or really know much about the process in general. So hopefully, you'd like to learn more about the overall operation of the technology from the user perspective. And if you're a president, a CEO, or a high-level executive driving this additive conversation internally, well, how easy is that to implement in my business, right? What's the learning curve going to look like? How much do I need to actually invest in the technology or in the training once I have the machine, at my facility? But if that's not the case, right, and maybe your interest is more in how will additive work for my business, and you're seeking more of a, let's say, an application identification resource. Well, one, I would first urge you to watch the recording of our last webinar a couple weeks ago, which was titled "Why Additive and Why Now?" And then reach out to myself or Andrew or Nick or other colleagues here at Design Point, and we can actually set up a more in-depth assessment on how additive can actually work for you. And that can be something that is done on site based upon obviously COVID protocol, or we can do something a little bit more virtual as well. And then I guess the third types of people that might be here is ones that have already adopted additive, outside of maybe the existing platform that we have or we're talking about today. And maybe your interests lie in, well, how is Markforged different from other FDM machines, currently in the marketplace, or why should I either replace or supplement my existing portfolio with a Markforged machine? Or maybe you have a Markforged machine and you're looking at our metal platform, or maybe you have one of our smaller desktop units and you say, well, why should I invest in one of our more robust systems, right? Whichever the reason for attending today, we're definitely going to make this fun, educational and very interactive throughout this process. So that actually brings us to our first poll. So Lori, I'll let you explain that a little bit further.
Yep. Also, people are like, why is that high-pitched voice? What is that I'm hearing? Because you forgot to introduce me. And they're like, is that Nick? It's Lori. Hey, guys. I'm head of marketing here at Design Point. As Charles was going ahead and explaining, the different avenues that might have brought you all here today, I did launch a poll. I saw that some of you went ahead and submitted your responses. We encourage you to let us know what brought you here today, or to drop something in the chat or in the questions. So far, the responses look like it's all curiosity. A lot of people here that have heard of 3D printing and want to learn more. If that's why you're here, I think you're in the right spot. We definitely have tons of resources. So we'll just give this another 30 seconds, place your votes, and then we will keep it moving.
Cool. So I'll go ahead and continue for sake of time, and we'll continue to monitor that. So based upon that, Lori, curiosity, I think it might be best then at this point in time, let's look back at the last webinar that we created a couple weeks ago, right? So the last webinar, we helped really paint a picture of really the additive market and the transition from prototyping and hobbyist applications to making really robust tools that have a really broad impact on the manufacturing side. We even shared a lot of examples where customers, big and small, are realizing major manufacturing efficiencies and transforming the way that their businesses are designing and manufacturing parts. Right, so some of the slides that you guys saw, if you were in attendance, previous, were like this, right? The fourth industrial revolution, digital manufacturing, big, bold headlines, where change is actually already taking place in a lot of these industries right now. We even took the time to break down all of the past revolutions that have occurred and the percent of equipment that has and actually is continuously changing, right? This is the notion that the way that we've done things in the past won't get us to the same results today, right? We need to adapt to survive. And then we went into, the efficiency gains that could be expected when you invest in additive, right? And we placed them in these three buckets, right? We have improved speed. So we showed examples of like response times on bids in, many different industries. We focus a lot on the defense side. And then we also talked about, PPE currently because of the healthcare and COVID scare, right? Being able to quickly and rapidly respond to the industry needs and produce that type of gear. And then bucket number 2 was kind of focused on downtime, right? So we looked at automotive examples where seconds in a fully automated assembly line could cost millions of dollars. So if you had, this digital inventory, digital library of parts that are continuously breaking down, what if you could print those in a couple hours to get that manufacturing line back up and running? And then greater yields, right? The fact that so many companies think that they're kind of stuck in their existing designs because it would cost maybe too much money or too much time to try and improve that. Right? This is the notion that if complexity was free, could you afford to take more risks? Well, probably so. And what would you do with maybe all of the operating efficiency? Right? Could you move that into more of a positive position, for your company? And then we identified that, well, guess what, right? The benefits of all this go way beyond just manufacturing efficiencies, right? This is totally changing the way that our customers are doing business on a day-to-day basis, right? So we talked about, well, lowering production costs, having a direct improvement on the company's ability to compete, right? And then the machinist talent, guys, that's at an all-time high right now. And most want your machinist focusing on the highest dollar value jobs that you have coming in. And then we looked at, well, is additive allowing companies to get new products, to market faster? Well, yeah, they definitely are, because we're decreasing the product development cycles dramatically, and we're cutting out a lot of the middlemen. And then, one of the last items we talked about was actually reducing the amount of money spent on holding physical inventory, because we've now moved a lot of that to a digital inventory model, right? What would you do, or how much more cash flow would you have if you didn't have to hold millions of dollars of inventory, each year, right? Those are a lot of the, larger business problems that, the CEOs, presidents of the companies that we're talking to are focused on. And we identified that, yes.
If I could interject, I think this is a great segue into another poll, because I think that some people inherently maybe know some of this stuff, but we're hearing people are curious about 3D printing, but I'm curious as to why maybe they haven't explored it a little bit further. So I'm going to launch another poll for all you folks out there, and I saw that a few different people have also joined us since then. I'm curious to know, why haven't some of you considered additive before? Total transparency, remember this is totally anonymous, so we can't see who sends what. Was it because of price? Not sure if there's a fit, or you just might not know enough about it. Curious to hear what you guys have to say about that.
Yeah, that's great. Perfect timing.
Yeah, see some people are saying they don't know enough about it. Most people on here. A few people still haven't replied. So I'll give it a few seconds. Okay. The majority vote is definitely, I guess, education there. So I'll close this out. You take it away, Charles.
No problem. So, again, backing it up a little bit, all of this, we're trying to figure out what that means. And in general, it means a lot of change. Well, a lot of great change. And, one of the companies out there that's really paving the way for change and leading, this forward movement in additive is these guys, Markforged. So, again, this is the platforms that we're here to talk about. Maybe some of you previous have done your own investigation on Markforged and what our differentiators are. But I do want to cover this before we take a deeper dive into the machine, because there's probably some questions that might come up when we're looking at the machine that could potentially be covered quickly in these next 5 minutes. But in order to really understand, I guess, why Design Point decided to choose Markforged over any other OEM that's out there, why we decided to represent them, we have to, I guess, look back at the last 30 years of additive. Yes, additive manufacturing has been around since the 80s, for those of you that didn't know that. And when you do that, you understand that it's been really trapped in prototyping, right? Toys, weak plastics, which are good, right? Fit checks are great. Maybe you're, again, hobbyist categories and you're making Star Wars action figures and Yoda heads. Okay, cool. We have a lot of people in the company that do that, no problem. But as soon as you were to put those into an active environment and you're looking at functional situations, they're going to fail immediately. So I guess why would Design Point even consider bringing on a partner that prints in those materials if our customers, aren't asking for it? Well, the answer is we wouldn't, and we didn't, right? So we surveyed a lot of our customers, and the number one thing that they requested was strong parts. So we thought to ourselves, right, which OEM out there is producing the strongest plastic parts in the world? Well, it's these guys, it's Markforged. And that's where our journey began. And now, we're almost 4 years later, we now support over 300 companies, 500 machines from Maine to Virginia, and are the #2 partner for Markforged in North America. You can quote me, we will be #1 this year. And Markforged was named one of the fastest growing 3D printing companies in North America. We're talking 12,000% growth since induction. And now they're backed by companies like Microsoft, Siemens, Porsche, and a couple others. But it's not just because these machines print strong parts that they're successful, right? It's because, unlike most, Markforged has created this industrial 3D printing platform, which is the makeup of not only the hardware, which is the printers that we're going to talk about today, but also proprietary material and software to create this closed loop ecosystem, which in turn provides a very seamless experience for our customers. Well, okay, so those are some of the reasons why Design Point chose Markforged, right? But why do manufacturers, why do businesses choose Markforged over others? So here is a comprehensive view of things that we've seen customers tell us specifically on why they decided to go with the Markforged brand over some of the others that are currently in the marketplace, right? So one is a comprehensive portfolio, right? So with Markforged, you can print a full range of materials spanning from plastics that are already 2x stiffer than industry standards, like an ABS or PLA, to composites, right? So now we're making something that's 2x, now go to 23x stiffer. And we're talking about actually replacing a lot of aluminum components with plastic and composite parts. And then we have metal, which is awesome, right? And then we have strength and accuracy, right? These platforms deliver strong, accurate, and high quality, repeatable parts. And the machines themselves are extremely reliable, right? I wouldn't be doing this live look if I didn't think that they were. I wouldn't have one of these machines in my house if it wasn't reliable. Trust me, my wife would kill me. But we hear things like that all the time that, man, 3D printing isn't for me because it's not accurate enough or it's not strong enough. Well, we're here to challenge that status quo now. And that's the reason why the Navy and Marines use Markforged machines, right? These guys are deploying with this technology to the most brutal of environments and using this to print a variety of different applications. And then you have accessibility, right? Easy to use technology, which I kind of just talked about a little bit. Put simply, these platforms just work. They're very reliable, easy to use, to maintain. I'll talk a lot about the maintenance programs / maintenance schedules, which is very minimal, during this live look. And then we have metal, right? So our Metal X, which Andrew's going to talk a little bit more about, you don't no longer need, to build out this massive facility, right? You don't have to walk in with a bomb-proof suit on. You don't need to dedicate a lot of huge resources and training and expertise to level metal 3D printing now. It's very easy to use and affordable. And then lastly, these guys are an innovation leader, right? They have patents protecting their process of continuous carbon fiber printing. They were first to market, right, with a safe and affordable metal printing platform, which is the Metal X. Not to mention a growing portfolio of industrial materials. They keep on spitting out more and more. I'm surprised how fast, actually, in comparison, that they're able to actually run through and manufacture, because they do a lot of their manufacturing themselves on the materials. But they don't stop there, right? They now offer a platform running on industry-leading software, and they also leverage AI to increase accuracy through really instant machine learning across a global fleet of printers. We're talking, 15,000 plus, and that was, I think, at the end of last year, right? We're already halfway through the year now. And the AI platform is something that we might even host this whole separate webinar later on down the road, and it's called Blacksmith. If you'd like to learn more about that, you can go to our website, or you can go to the Markforged website directly and learn how that interacts with our machines.
I think that's awesome, Charles. I know that we're almost halfway through here, and we're going to get to the super meaty stuff with the printers. But you saying that, I just wanted to let everybody know that I dropped a quick handout as you're speaking about the Markforged platform. Digital Forge has a lot more details on that, so you guys can take a look at that after the webinar.
Perfect. All right, so real high level, and then we're going to take a look at the machine. So want to talk about the whole platform, right? So that includes the hardware, software, and materials. So quickly, this is a quick snapshot of all of the platforms that we currently offer, and there are multiple machines in each platform. Starting on the left is a desktop. The one directly to the right of that is the industrial machinery machine. There's 3 machines in that series. That's the one I'm going to be focusing on. And then the 3 machines directly to the right of that is the printer, wash, and sinter. That is a full package, and that's what Andrew's going to talk about as well. Okay. And then we have obviously our materials, right? So we started out in plastics using a very strong material called onyx, which is a nylon and chopped carbon fiber material. It's very important that you understand the difference between like a thermoplastic, like a filament, and continuous material, because we are the only company that has patents on actually producing continuous composites. And I'll talk a little bit more about when I go to the machine, and I'll actually show you physically spools of that. You're actually routing material on the inners to make that part really directionally strong. And then we have metals, right? And metal is metal, right? And we have a lot of metals that we can talk about. Andrew's going to talk a little bit more about these, right? So we're running from stainless steels to alloys and, you know, Inconel 625 to a lot of tool steels, things that have been traditionally very hard to machine. Those are the things that companies are focusing on today. Okay. And then you also see a lot of our companies that are involved in this new manufacturing process, creating hybrid parts. So they have multiple platforms, right? They have a composite platform and they have a metal platform, and they're utilizing both together, right? So they might print a wear item that's picking up something that might be sharp and that would normally wear plastic. They're printing that on the metal side, and then they're actually physically producing the strength of the part to make it really lightweight and affordable in our composite material. And I actually have some examples, and I'm sure Andrew does as well in the lab, that we can show you. And then lastly, again, before we take a deep dive, the back-end software that's happening, right? So we have a proprietary software platform called Eiger, E-I-G-E-R. It is basically a slicer / part repository, and you're able to control a fleet of printers from this one platform. It can be cloud-based, which is great. We have local storage options as well, and then we have an offline platform. For example, if you're one of our defense or military partners and you can't necessarily use the internet, you would go with a platform that looks similar to that. Okay. I would love to do a full software demo today. We don't have enough time to. Maybe it's an opportunity for us to actually create a whole new webinar dedicated on just, hey, how do I actually go from my CAD to Eiger and slice everything and manipulate those parts? Lori, let's jot that down. Let's actually do that. And maybe we can actually incorporate design for additive in there as well. Like, hey, I need to create this part specifically around the platform or the tool that I have, which might be a Markforged machine or maybe another machine, so that you're utilizing those best practices. But in general, so since I have a machine at my house and I print parts every single day, what I do is I take the CAD file. So we use and operate on SolidWorks. Some may operate on a different platform. Happy to have a conversation about that as well if you'd like to switch. And then we basically export out an STL file, right? We take that STL file, we import it into our proprietary software that comes with the machine. It's free. You get unlimited licenses if you want to designate those to operators within your company. We slice every layer, which basically slicing is taking the resolution and making up a number of layers So let's say we use, 100 micron layer resolution. It's going to slice that part as many times based upon that value, and it'll spit out a metric. So maybe there's 162 layers or 5 layers. It depends obviously on your part geometry. You'll make all the manipulations in the software, which again, we can have a separate webinar for that. And then you send it to the machine, which is basically pressing a button, and you walk away and you come back with your part, after that time is up. Okay, so it's very simplified, but let's talk a little bit more, again, for sake of time, about how to do that. So again, I told you I was in my house, so I'm gonna try to turn my screen the best I can, and then walk you guys through step by step on how to start a print. Well, not really start a print, I actually have one going. But how I would go about doing that if I were to start a print. We'll talk a little bit about the materials and the overall hardware itself. So give me 1 second. I will change my viewing screen.
While Charles does that, by a show of hands, you can raise your hands. Raise your hand if this is the part that you've been waiting for. I know I have. All right, starting to see some people do that. And then last thing is, if you actually hover over Charles, like where Charles' face was originally, you'll see in the lower right-hand side, there are 2 arrows. You can actually click on that to expand the view, just so it can take over more of your screen and you can see that more comfortably.
Great, yeah, thank you, Lori. So we're gonna do this twofold because unfortunately my wife is taking care of my daughter right now and couldn't be my cameraman. I'm going to go a high level view right now of everything you can currently see. And then I'm going to physically walk to the printer with my camera, and then we'll kind of go inside of the machine and around some of the other components, okay? So what you're seeing right now is the printer itself, right? This is the X7. It is a floor model machine. The iRobot right here does not come with the machine. And then you have a USB battery backup right to the right of that. I live in a very old neighborhood and we have above ground power. So I just like to have it on hand if for some reason we have a storm. To the far left is a Pelican case. As I mentioned, the Navy and Marines tend to use these machines and deploy with them. And usually pre-COVID, I would physically bring machines to customers who can't necessarily get out to one of our labs, and I would do a full demonstration. That's the versatility of this. So that's the reason I have that. And then you'll see some dry box material right here, and then some of your material containers to the left. This is just kind of my little remote setup here at my house. All right, so let's walk a little bit closer to the machine, and then we'll kind of go over all of the nuances. All right, so let's start to the full left, right? A lot of questions usually start with, well, what does my material look like? How does it come? What do I have to worry about? Your material is actually gonna show up in either this nice gold packaging, right? This is our golden ticket. And those materials are our fiber materials. So when we talked about continuous material, this is what we're referring to. And we have 4 of those. We have continuous carbon fiber, we have a high temperature fiberglass, a regular fiberglass, and then a Kevlar material. Those spools will be loaded in the machine here to the right in a back corner, which I'll show you here in a second. Then you have your filaments, right? We have a variety of filaments that we can run through this industrial platform. It actually runs the full suite of all our materials, which is that onyx material we briefly mentioned. We also have a flexible white nylon, which is a nylon 6.6. It's made with food grade materials. Happy to talk about that further if you have those types of applications. And then we have more certified materials, like if you need something to be self-extinguishing, we have an FR version. So a lot of our partners in the federal and defense and aerospace industry are using that on a variety of aircraft. And then lastly, we're coming out with an ESD-like material for static dissipative applications if you're working with any electronics. So these are coming in sealed containers. Great thing is they will not expire if you don't open them. And there's no chips involved either. So it means that you can always use them. I know some other machines that are out there, wire those with chips and you can only use them for about 6 months. And if you're spending a lot of money, right, you might as well get the full satisfaction of those. Now, our filament material has a base material of nylon. So you're noticing these 2 Pelican cases that are directly above these. These are dry boxes. They come with the machine. One comes with the machine. I just happen to have two because I go back and forth between a variety, and it's more of an easy setup for myself. These are actually normally down here in your base cabinet, but because of this demonstration, I don't like necessarily getting down here. I got bad knees. This would normally have a feed tube from the back of the machine to this, and you'll have some storage in here. So I have a variety of different consumable components. In some cases, if you have very tight space and you're saying that, hey, Charles, I don't even have enough space to put this thing. Some might even put it up on a desktop, but physically the top of here removes from the base cabinet, and you can go ahead and put that up on a shelf. But in general, you have a spool, and I'll go ahead and open this up for you so you guys can see exactly what it looks like. Basically, this is a spool of onyx material. It's an 800 cubic centimeter spool. You have desiccant powder that comes with the actual package that you'll transfer upon delivery. And then you'll have a Bowden tube, which you can kind of see to the right, is coming out of the Belkin case itself and into the machine. So as I come to the machine, we'll go ahead and open up the top. Just a note, this is an office-friendly piece of equipment. Again, we wouldn't have this in my house if it wasn't. It doesn't put off any VOCs. A lot of that has to do with a couple different factors. One, it doesn't require a heated chamber. And two, we're working with nylon, which doesn't put that off. So you're not running things like ABS or PLA, which are some other industry standard thermoplastics that actually put off those types of chemicals. So as you look in, I'm actually currently producing a part right now. This is a door hanger, which we won't get into a full depth on right now, but it's basically a PPE version during COVID, so you don't actually physically have to touch the door. But as you look through, you see that Bowden tube actually physically stretching to your first extruder. So basically this is pulling the material through to another Bowden tube, which will eventually reach your print head. So we always think of it like a hot glue gun application, right? You're melting material. This just happens to be melting it into a three-dimensional object. The print head is the only thing that's actually physically getting hot. None of this is heated. It's just putting off enough heat to rid any moisture contact to make sure that you have a superb finish on your parts. Now, we also talked about that composite material, right? The fiber. If you look really closely in that back corner there, you see a tiny spool. That is a spool of carbon fiber. They come in different sizes, of course. And this one has its own Bowden tube. So it's stretching up to its own extruder as well. And it's pulling the material again around through here into your machine. Now, the great thing about this, they call it a dual extrusion technology, which means it has the ability to move from one material to another. So there's an internal chopping mechanism that's built in there that'll allow it to do so, which also means it has two nozzles. So as I lower down into the machine, you might be able to actually see this. One is being produced with this onyx material and the other would lay in a continuous carbon fiber strand. Okay. Now we can also pull this up. This is a visor, right? This is just a kind of from a safety perspective, and nothing's gonna harm, but it's just a precautionary measure. So you can lift this up. And then this is where you can actually see the machine. You can see the spools to the left and the right. You can control the machine via this digital interface, which basically means that you can kind of understand when I'm printing something, how is it doing? What layer is it on? I can actually physically pause this machine. And the great thing about not having a heated chamber is you can insert things like magnets or ID chips, pieces of metal to make your part stronger. And you can program the machine to do so. Whereas here, if I wanted to just briefly show this, I can come over and press the pause feature. This build plate will actually lower down. The machine will go back to its home, and I could physically remove this without harming the print whatsoever and take a look at what I'm actually creating. Now on the back of this build plate are magnets, right? There's 3 dots, 3 magnets that match up with locator tabs on the machine. So once I've done my insert, let's say I'm going to put in a magnet there, I put this back on and I press resume right here. And there's a laser actually affixed on this print head that'll come back to that exact same spot where it stopped and pick right back up. And if you've programmed it the right way, then you'll go ahead and either embed that part fully, or it's actually going to move around that part. Okay. Now that laser we talked a lot about as well. That's one of the big differentiators between Markforged and many other machines that are on the market. It's one of the only lasers that are built in, and it's for bed level, right? I'm not sure if anybody on this this call has a more hobbyist machine. Leveling the bed seems to be very difficult when you have those types of investments. Whereas here, this is removing a lot of the manual process from it. So it'll actually take scans of your build, in addition to taking scans of the bed, and it will self-level to make sure you're accurate 100% of the time. Right, that laser is also for in-process inspection. So if you have a critical tolerance in a particular layer, you can tell it to stop on that layer. It'll send you an email with the data, and you can measure that data and either continue on or make the change back in your CAD. Okay. Andrew, how am I doing on time?
That's so funny. We were just about to tell you. We've got
okay, great.
15 more minutes, so wrap it up so we can see the Metal X.
All right, let's wrap it up then. So again, this is an older machine. This is about 3 years old. The only differences are updated extruders for high precision, right? So now we have accuracy of 50 micron on this machine. The color looks a little bit different. This is more of a bluish gray, whereas the new ones are more of a dark gunmetal gray. But other than that, everything is just very well built, aluminum chassis. Yeah, man, this thing is the workhorse of the machine. I love having it in my house. I don't really want to go back to the office because I don't want to take it back with me. I just want to keep it here, which is nice. So hopefully that gives a really good high-level overview of how this technology works and operates. I had this running off of Wi-Fi. We also have Ethernet applications and obviously no Wi-Fi as well. But yes, definitely a well-built machine. Any questions before I go ahead and give the reins over to Andrew to talk about the metal machine while we're focused here on the X7? Nope. Okay then. So with that, I will go ahead and give it to Andrew for the next 15 to 20 minutes here, and he can go over our best-in-class metal system. Andrew, take it away.
Sure. Thanks, Charles. That was awesome, very informative. Thanks for giving us a look at the X7 there. So now I'm going to show you guys the Metal X. The Metal X is a 3-step process. It's print, wash, sinter. There's an FDM 3D printer, a wash station, and a sinter furnace. So that's what we're going to do. We're going to start with the printer and then go to step 2 and step 3. So the process is at a high level, a lot like metal injection molding. Metal injection molding, the process would be mold, wash, and then sinter. So in essence, what this is, in a nutshell, it's metal injection molding without a mold, right? You don't have to spend tens of thousands of dollars on a mold that you can only use for one specific product. This printer is, in fact, every mold you could ever want, right? This is going to print the geometry. So in metal injection molding, basically you take powdered metal, wax, and binder, and you'd shove it into a mold, and you'd pop it open, and then you'd have your geometry. So with this system, you're simply printing that geometry instead. So we'll dive into the printer here. Like the printer that Charles was just showing, this is an FDM 3D printer, which is a fancy way of saying that the material is on a spool, the filament's on a spool, and it passes through a hot nozzle, and then the print head moves around in a gantry and deposits the material where and when you want it. FDM 3D printing is the oldest type of 3D printing. It is the easiest and the simplest. So from an operator standpoint, it's really awesome. The maintenance on this machine is very minimal. It's very easy to use. And I'll talk a little bit about that in a moment. But let's take a look at the printer. So you have the material up on the top here. On the left-hand side, you've got your metal, right? But it's not really metal, because if you had metal on a spool, obviously it wouldn't unwind. So what it is a filament made out of powdered metal, wax, and binder, just like metal injection molding. If you want to change your material, this little cap is magnetic, comes right off. You pop a new spool on, and it literally takes about 5 minutes to change from one material to another. So you could be printing in 17.4, and then 5 minutes later, you're printing in A2 tool steel or Inconel or copper. And really, the only reason it even takes 5 minutes is because you're waiting for the machine to heat up. This is a heated chamber, heated bed on this machine. On the right-hand side, you have a ceramic material. So what the ceramic does, it acts as a release layer in between the parts and supports. So if you're printing a part and it's got an overhang, it's going to create metal supports. It's going to be whatever material you're printing in, the supports are made in underneath to support the overhang. In between the two, there's going to be one layer of ceramic, and that's what's on the right here. And when the part comes out of the sinter furnace, similar to like this part you're seeing here, it has this the support, this raft on the bottom. Comes out of sinter furnace, you give it a little whack on the table or hit it, tap in the back with a hammer, and this pops right off because of the ceramic. So that's the purpose of that. Now, as far as usability, this machine is actually even easier to use than the composite side, which is already really easy. And the reason is you don't really have to do anything. This machine does its own bed leveling before you start. Actually, when you install the machine, you do the bed leveling once then, and then you never have to level it again. You know, show me another FDM 3D printer where that's the case. The only thing you really have to do is when you start a print, you hit a button which turns the vacuum on, which is in the build plate there. And once the vacuum is going, you take the sheets, and this goes on top, and it sucks it down. So that way you have a really nice printing surface, excuse me. And then when the print is done, you simply disengage the vacuum, you pull this off, you bend it, and your part comes right off. So parts are really easy to remove. There are other platforms like laser metal systems where you have to EDM your part off the build plate. So that's not the case here. Parts are very easy to remove. One consideration with these machines is maintenance, right? All right, so what's the upkeep? What does it take to keep these machines maintained? Very minimal, very minimal. You've got these little nozzles that screw into the bottom of the print head, one for ceramic, one for plastic. They're about this big, and you swap those out maybe every 3 months. So, you know, a handful of times a year. There's some pieces of small tubing that get replaced. They're like 50 cents each, very, very minimal. And the gantry, you grease that probably every 3 months too, with a little syringe of grease. You go around, give it a little grease and move it around, and that's about it. So really, you just get on the software and you get your part prepared. You come with the machine, hit the vacuum, put the sheet on, hit print in the software, and away you go. And it's really set it and forget it. You don't have to be here hovering over the machine or anything like that. Similar to Charles's printer that he was talking about, there's a user interface here, and it's very self-explanatory. So if you're going to do a piece of maintenance like replacing the nozzle, for example, you go on there under utilities, maintenance, replace nozzle, and we'll literally take you step by step through the process of doing that. So again, very easy to maintain because this is an FDM 3D printer. So that's about it for the printer. It's really a fairly simple machine. You can see here, I'll try to move back a little, kind of the scope and the size of it. It's really not that big. It's about the size of the X7 that Charles was showing. I mean, I could pick this up if I wanted to. I won't, obviously. So that's really the printer. It's got a built-in camera, so if you want to monitor, you know, your print from far away on the weekend, you can go into the software and you can take snapshots through the camera. And yeah, I think that's it for the printer. So I'm going to go ahead and move on to the wash station. So now we're kind of going from FDM 3D printing into kind of that metal injection molding side of it. It's really a combination of the two technologies. So I'm going to go ahead and move my table here. I'm sorry, go ahead.
Oh, no, go for it. As you're moving your table here, I'll just ask really quickly. I want to make sure that I manage expectations for everybody in the room. It is 11:52. Andrew does have a few, things that he wants to show us. If you guys could just raise your hands if you guys are okay with, maybe going over by 5 minutes. If you're not and you jump out, that's totally fine. But we want to make sure that we show you the full metal 3D printing process. So Okay. All righty. Sounds good. Go ahead,
right.
Andrew.
In the interest of time, I will keep plugging along here. So this is the wash station. It's a pretty simple machine. It's machines like this are found in auto repair garages to clean tools, and basically it's a bath in a solvent. This is where I make the French fries, JK. So basically your part goes in the basket. There's nothing locking the door or anything like that, just opens, you place your part in, and then you tell the software that the part's in there, and then it will actually tell you, when your part is completed. And then once your part is completed, there's this other station here, which is a drying station. So your part goes in here, and the solvent evaporates through the ventilation here. It's a pretty simple machine. Maintenance on this is very low as well. About once a year, you're going to have to empty the boil chamber, which is basically collects the wax. And that's really what this machine is doing. It's simply a wax removal machine. So you're going to place your part in, the solvent's going to dissolve the wax, and leaving the part porous for the next step of the process, which is sintering. So when the part is sintering in the sinter furnace, it's important that it's porous because there have to be channels for the binder to vaporize and exit out of. So the wash station was a wax removal machine. The sinter furnace is a binder, a plastic vaporizer, basically. So once you use the wash station, you remove all the wax from the part, and then in the sinter furnace, you're removing all the binder, and then in the end, all you have left is metal. There's none of the other ingredients left. So the sinter furnace actually isn't common. Usually these furnaces, they could be the size of a room, they could be, $500,000, running on pure hydrogen. This does not. This runs on argon, which is inert, excuse me. There's no flammable gases. System is very safe. Probably something I should have pointed out with the printer as well. I'll just jump back here real quick. One thought I wanted to share with you guys is the safety of the system. So other systems that use like a laser sinter, they work with loose powder. Loose powder is really toxic. It dissolves through the skin, and it's highly explosive. And they're shooting a laser at it with those types of systems. So this system, all the powdered metal is actually encapsulated in wax and binder. So you can open this door, and you could reach in here and actually touch the part as it's printing, and there's no safety issues there. So safety, big concern. Same thing on the sinter furnace, all argon gas only, nothing flammable. Let me set up my computer again here. Talk to you guys about this. Okay, here we go. So sinter furnace, again, easy to use. Does all its own safety checks before you start to make sure you have gases in the right place and everything's supplied correctly. But basically, you have an aperture at the end here, and it doesn't matter how many parts you put in. It's basically as much as you can fit onto the sinter plate as you can goes into the system, and then you sinter, and they come out at the end just as real metal. So what can I tell you guys about this? Well, this is Sinter 1, first of all. This is a 6-inch diameter tube. The build plate is 12 inches. If you're looking at Sinter 2, Sinter 2 is much larger. It's I believe a 10-inch diameter tube in there and a 16-inch build plate, so it's much larger. So the reason why you might want Sinter 2 versus Sinter 1 is if you're printing either a large volume of parts or if you're printing larger parts. Sinter 1 is good as well. It's just for parts that are about the size of a fist or smaller. Let's see here, that's about the size that fits in there. This over here looks complicated, but it's really not. It's very simple. This is the gas control panel, controls all the gases. This is your argon, And it's very smart. There's a communication cable from the gas panel to the machine, so it knows exactly what's going on at all times. And this just basically tells you what's going on. But basically, it's going to run some argon through the system during the sinter process to ensure, you know, the chemical reaction with the part. But yeah, that's about it in a nutshell. Print, wash, sinter, maintenance on this machine. Every 40 runs or so, you have to go in and clean out the exhaust system, which is pretty minimal, and there's some filters you change out kind of on a regular basis. But other than that, really not too much to speak of there. And that's about it. Charles, any obvious things I'm leaving out here?
Yeah, it's very high level. I want to make sure that everybody understands that, for those that are really serious about deploying a metal system within their facility, let's have a bigger conversation about that, so you understand kind of how the science behind it. We want to make sure, obviously, within this webinar that we give you just the high level basics and the great nuggets to take back with you to really understand how easy this is to operate. One thing that most people bring up to me is, that they want to print in a variety of different materials. And with other systems that are out there, it's very hard to go from, let's say, a copper material to an H13 material, in the same day. Well, it is impossible if you have a powder-based system. Can you talk a little bit more about the easiness to do that, Andrew? And I have a couple parts that I can just show up here while you're going about that, not just with the printing process, but also with the sinter process and how that's being calculated on the back end by Markforged.
Sure. So you have a number of materials available from Markforged. You have 17-4 stainless. You have a number of tool steels, A2, D2, H13, Inconel 625, pure copper, and it looks like the next ones on the short list are going to be titanium and 316L. So what's really great about that is, depending on your application, you could very easily swap out materials, like I showed on the printer before, and be printing in the material of your choice. On the sinter furnace, all of that is done behind the scenes. So, you have to sinter certain materials with their own material. You can't sinter a copper part with a, let's say, stainless steel part, because the actual heating cycle in the sinter is going to be different. So in operation, you don't have to worry at all about, well, what cycle do I have to have for copper? And all that's automatic. It's on the machine. When you're starting the sinter furnace, you choose your material, and it automatically loads in the correct heating cycle. And again, it's very much set it or forget it. It's roughly a 24-hour process. Put parts in, next day they're done. Although there is a turbo sinter process on Sinter 2, which is shorter. I think it's about 17 hours. So Markforged, same with everything they do, they're continually working to improve these processes and make these run shorter. But yeah, it's basically all run by the software and the firmware. You do get a firmware update on the machine every few weeks, so there's constant updates. But basically, I'm going to try and maybe show the user interface here. Let's see, yeah, you got the user interface here, and everything runs through that. And basically, you want to print, you just hit Start Sinter, and it runs you through a few safety checks and pick your material you want. And I'm not going to go through the process because I don't actually want to start the sinter. But basically it says, hey, did you remember to close the door? Did you remember to wash your parts? Runs through some basic safety stuff, and then go ahead and sinter, and away you go. As far as different materials in the wash station, those you can batch together. So those, you're going to be washing copper parts with 17-4 all at the same time. Doesn't matter. You can throw anything you want into the wash station.
Yep. Thank you, Andrew, for answering that. Part of our proven process here is, we're not just going to, sell you a machine and say, bye. This technology is advancing very quickly and has so many uses that many of our customers are buying secondary machines in the first 9 to 12 months. So we're very heavily invested in making sure that you guys are understanding and are fully operational, day one of install. So Andrew is one of a couple technicians that we have, throughout our territory, which again is Maine through Virginia. And we'll come on site and we'll teach you all of the tricks. Not obviously just, installing the machine and showing you how to operate that, but design modifications, design guides. We've been doing this for almost 4 years now. So we have a great stack of best practices that we're going to provide to you to make sure that you are fully operational day one. And I know in my conversations with so many little high-level executives, that's what they care about, right? They don't want a 3-month, 4-month, 6-month ramp-up period. That costs the company way too much money, right? They want to be able to print a part and get a part in their hand as quickly as possible without having to involve a lot of costly engineering time to do so. And that's, I would say, the biggest differentiator between a Markforged platform, composite or metal, in comparison to everything that's out there, is your involvement in this process. Andrew said it and forget it. It just reminded me of the old school rotisserie commercial when you're drooling over the meats. But it's exactly what it is, right? To be able to get work done while you don't even have to be there. This machine is here to make you money, to make that company money, to make you more efficient. That's it. So I would say, based upon time, if there is interest, right, in learning about this process further, we're more than happy to do a more individual one-on-one demonstration. We do multiple a week, whether that's composite or metal, with your company, and you can involve multiple members of your team. Myself, Andrew, Nick, who I mentioned earlier, all great context to connect with. Again, we'll be sending out this webinar that you can forward along to other members of your team. But I just really hope that this was a little inspirational, so you guys have a better understanding of how companies are, one, using additive, as well as the differentiators and why we chose Markforged, over the other OEMs that are out there, and really, again, how easy this technology is to use. It's not rocket science. I know it's sometimes drummed up to look like that, like, oh my God, I'm scared of additive. What is it? It's just, once you have the education, once you know, the types of things and the types of problems that it could solve, it's such a no-brainer for so many companies. We love what we do day in and day out. It's great to see how many companies are using it for things that we never even thought about before. Because we're following up in 45 days, to do an assessment, and it's like, wow, you used it for this and this. That's awesome. Well, you got an ROI in 3 months. Wow, can you talk about it? Because those are the types of things that you're going to see, when you really sit down and decide to make an investment in this portfolio, because it's going to be a competitive advantage. But it won't be, in the next couple of years. It's going to be a necessity for your company to compete in many areas of your business. So I'd like to thank everybody again today for joining, and let's open it up to any other questions that you might have.
Just going to monitor this here to see if anybody asks any questions, but I think that was a great summary, Charles. Biggest takeaways, right? A lot of people told us that they came here because they were curious, so super educational. Thank you guys for catering to that request. And then safety, I think, is also super recurring. Not sure if a lot of you guys caught wind of this, but Charles has a toddler and a newborn in his house, and he has that machine running, right? Yep. Andrew is dealing with a metal machine. You did not see gloves on his hands. You did not see him with a face mask. These are super safe. These are mobile, right? This is really how we can empower manufacturers, the modern manufacturer. So waiting. I do not see any questions still. So that means you both did a fantastic job at just educating right now. But I hope you guys aren't shy and that you follow up accordingly. We definitely will be. And like Charles said, the recording, you should receive it. I'll actually say probably within, probably by Friday, end of day, just to be safe that we process it accordingly. But that's it for me. No questions here.
Sounds great. Thanks everybody for joining us today. Enjoy the rest of your week.
Thanks, everyone.